Today we're going to finish up our Enclosure Restack series by adding a few things that are going to make your 3D printers as easy to use as possible. Hello everybody, Chris here, and today we will be finishing up our Enclosure Restack series. But this video is about all the fun stuff. These are all the items that I would add to multiple 3D printers, like in this enclosure, or in a 3D printer shelf, that just make your life easier. I've learned a lot of tricks that you can do using Octoprint, adding multiple camera feeds, as well as plugins that help you with maintenance of your 3D printer. And we're going to include all of that today. So let's not waste any time. Let's jump into installing Octoprint. We'll get all that set up, and then we'll move to creating some parts to help us with our cameras and just get everything all nice and ready to go so we can start sending files over to both our 3D printers and start cranking out some parts. Let's get into it. So here's what we're working with. We have a Raspberry Pi 3B. This is more than enough to run both of those printers. I had an extra one laying around. I know they're hard to get. I am working on more content on Octoprint, so you don't have to have a Raspberry Pi. Stay tuned for that. You'll need an SD card for this build and a power supply for your Pi. I also found this injection molded case I had laying around. The backing for it is already on the enclosure. It had some mounting holes, so I'm just going to use that because it was convenient. We have two Logitech C270s, affordable cameras. They got a nice long cord. We can run them to the back of the enclosure. For the Prusa machines, we need two USB cables. This is A to B on the older style board. And then two 3D printed mounts for those cameras. I worked on these a bit to try to get the Logitech. It just goes in the standard mount. So you don't have to alter your camera any. They just slide right in here. And then you can position them how you want. It is kind of tricky in that lac enclosure to get it pointed at the center of the print bed, but I did my best to design these parts so that'll happen with that concrete paver, making the printer a little higher. So now let's boot up our Pi, get everything configured before we take it over there and get it installed. So here's our brand new fresh install of Octoprint. I am assuming you know how to get it set up, at least on your SD card. If you don't know, there will be a link in the description for a video. So we just need to run through this wizard really quick. We're doing multiple instances here on the same Pi. Remember, a lot of these settings will be shared. So don't do a lot of customization until we get the second instance stood up. So we'll just run through these. And really, during the wizard, the only one that I would be concerned with is the printer profile. Now, if you're using two different types of printers, you might not want to fill this out quite yet. But we're using two Mark IIs, so I'm just going to let them have the same settings. So Prusa Mark II, and we'll just call the model Mark II, whatever you want to set these at. You can update the bed sizes. So 250 for us and 210. Axes, the only one I like to change is E. I like to set it down to 100. So in case you're doing some calibration or troubleshooting, it doesn't move so fast. And then hot end extruder, it's already going to be set to a 0.4 nozzle, so we're good there. We'll hit next. Remember, same settings, both instance. No matter what you set here, it's going to copy over here in a second. So we're finished. Now I want to go ahead and make that second copy before we continue any further. Now I've showed how to do this many times, and I'm going to show you later on in another video the easy way to get multiple instances set up with Octoprint. But since we're only doing one, it's just a couple of commands, and I have a doc out there that you can just copy them from. Basically, this is my cheat sheet document for multiple Octoprint instances. A link to this in the description. You can just copy what I'm getting ready to do. But now we need to go ahead and use the putty tool to log in to command line and run these commands. I am using the IP of our Raspberry Pi instead of a .local address, because we're going to have that IP for other configuration items. So I just recommend using the IP going forward. So we'll go ahead and open. Use your default username and password. It's usually Pi and Raspberry. And again, we have a fresh install. Nothing's plugged into the Pi quite yet. We're just going to run these commands to get our second instance going. So from our Google Doc, I'm just going to paste in this copy command, cp-r, that gets everything. Our home pi.octoprint directory, we're going to make a copy into Octoprint 2 for our second instance. Then we're going to switch over to the root user, just because some of these commands, they're way easier to run as root than trying to do sudo. So do sudo SU. That will get you over to root. You will need your password again. And we're going to change directory into etc/systemd/system. And we're going to use this giant sed command to swap out parameters in that file. Basically what this command is doing is switching out some of the IPs in this service file. It's making an alternate service file for Octoprint 2, so we can run them both at the same time, one on port 5000, one on 5001. It just saves you a lot of manual editing using this long command. Again, just copy and paste from the doc. Still as root, now we can update the service with systemctl enable to enable your second Octoprint instance. This will keep track of it and allow it to boot. When you restart the Pi, we've enabled that, and now we can go ahead and start it. Now we have two instances of Octoprint up and running on the same Pi, just a different port. So you can jump back to your browser, and we'll just duplicate this one on the main IP, and we'll just point the IP address at the new port, 5001. We can log in, same credentials. Everything from the wizard is going to be exactly the same over here. And now we have two instances running, one for each of our printers. Now we have to set up the printers and the cameras. I think the easiest way to do this is to just plug them in one at a time and figure it out that way. So back to the enclosure. This is the back of the bottom section where I've been mounting things. I decided to go with a 3D printed part for these WAGO connectors. It's still printing, but we'll set that up here in a minute. But this is that injection molded case I was telling you about. The Pi just sits in there, and then the top will snap on and hold it in place. And we can go ahead and plug in our power. And we can tidy these wires up once we know everything works. Now the next challenge we have is that USB cable, and we have a camera cable that are going to go inside this enclosure. So we're going to have to drill a hole that's kind of big. And I don't want to, but it's really the only way that we can get this done. The top enclosure, you can just kind of slide it in underneath the plexi. And I think the cameras actually work better in the front left corner. So I'm going to have that cable, this is the USB side of the Pi, I'm going to have the cable run out that way. So we can kind of hook it to the top of the enclosure and make our way over there. So we can go ahead and run our USB cable through for the printer. And we can run our camera in from the other side. But we'll go ahead and start with the bottom one, the bottom printer enclosure. So we'll go ahead and plug the camera and the printer in for that one. I'm going to do them one at a time so I know which one's which. Camera's through, and we'll plug it in. Now we can go ahead and power up and we'll configure that one. So let's tackle the printers first. I currently have the bottom printer plugged in. And I'm going to use this main one here for the top printer. In fact, I'm just going to change its appearance now that we've already done our copy. I'm going to call this Mark II top. And let's make this orange. And then the second one, we'll call this Mark II bottom. And we'll make it orange, but we'll make it transparent, just so it looks a little bit different. And this updates the tabs as well, so you can tell them apart in the browser easier. So now we'll plug in the bottom printer and the bottom camera. We'll get to cameras here in a moment. Let's take care of the printers first. With them plugged in, we'll go back to PuTTY, and we're going to take a look in the syslog file. So we're just going to cat/var/log/syslog. And it's very noisy. So I recommend you bring that same command up, do a pipe, and do grep. Just a find command, and we'll just look for USB. Now we have a lot easier time searching through all this data to figure out what's what. Here is the camera. I know it by device ID and the serial number. You don't really have to worry about that so much. We're just focused on the printer. We're going to do cameras just a little bit different way. So we need the ID vendor and the ID product and the serial number. And we need to update that in our USB config file. Again, that information is in the doc. So we can do an exit to get out of root, and we'll just use sudo for these other commands. But we're going to do sudo nano, our file editor, etc udev rules.d 99-usb rules. This is where we can enter the commands to separate the printers so we know which one's on which port. We can create a custom port. So from that doc, I'm just going to paste in the vanilla entries that we need. And then since you already catted that sys file, you can scroll back and get all the parameters that you're going to need. So for the printer, we need ID vendor, ID product. We have 2 Charlie 99 and 0001. So we'll just update that first line. 2 Charlie 99, 0001. We don't need dev path. That would only be for a printer that didn't have a serial number. Prusa printers do. And I'm going to go grab that. So I'm going to scroll back, and that's this number right here. And I'll paste that in there. And we know that this is the bottom printer. So I'm just going to call this new USB port bottom. So you can Control X, Y, enter to save, and we're good on that printer. Now I'm going to go plug in the top printer. We're not going to do the camera yet. We still only have one camera plugged in. But let's go ahead and do this top printer while we're working on printers. So the top printer's plugged in. Let's go ahead and take a look at the syslog one more time to get its information. Sudo cat /var log syslog. And there's the new printer we plugged in. I did mention before I had to swap out the board. This is my original Mark II. So you can see it has a different ID vendor, and it calls it an Ultimachine board. So it's just a little different than the Prusa would normally be. But we're going to go back and edit that rules file one more time to add this machine. Our ID vendor is now 27Baker1. Our ID product is still 1. Again, we don't need dev path because we have a serial we can use. And then we'll grab that serial number. And we'll call this symlink top. Control X, Y, enter to save. And our printers are set up ready to go. We'll update that device in the GUI here in a minute. But now we can work on cameras. I show this process in a video if you need more of a deep dive on how to do multiple cameras. But Octoprint does have a process for it. So we're going to change directory into /boot. And if you take a look in here with an ls, this octopi.txt is where you would configure your cameras. But we need to do 2, and you have to make a special directory to be able to do more than one so that it loads those out of that directory. It knows they're there because of that directory. So we're going to make that directory sudo mkdir make dir, and it needs to be called octopi.conf.d. And then if you copy that octopi.txt into there, it will load multiples. So we'll do sudo cp octopi.txt into that octopi.conf directory, and we're just going to call it webcam2.txt. So now we have a copy that we can use for our first webcam and then one for the second. Now we already have the camera in the bottom enclosure plugged in. We just need to know its device number. The easiest way to do that is to do an ls/dev /v4l/by-id, and that's going to list all your video devices. And you're going to have 2 indexes, 0 and 1. You only want index 0. The other one's not going to do you any good. And you need the fully qualified path. So if you copy that and just bring up the command with the up arrow and paste it in here and hit enter, this will spill out exactly what you need to call it in your config file. And now that we have that copied, we can do sudo nano octopi.txt, and we'll make the updates for it. On camera, take the comment off, change auto to USB. So it automatically tries to go to USB camera. It's not looking for a Pi cam. And then in camera USB options, you can update your resolution. Let's go ahead and make ours 1280 by 720. That's good for this C270 camera. And then within the quotes, you need to do a -D and then paste your fully qualified name that we just copied. That way we know that this OctoPi.txt is on this port number, the default port number, 8080, and it's this device. It's just an easy way to keep them separate. We can use them on multiple instances. That's all you have to do for this one. So Control X, Y, enter to save. And now let's plug in our other camera, the one for the top enclosure. So now that that camera's plugged in, if we repeat our ls/dev command that we used earlier, you're going to see two instances here. So our first one that we used above with this 8Fox60, that's this one over here. Our new one is this 9060. So remember, you want index 0. You can copy it, bring that command back up, paste it in there and hit it. That will give the full qualified name. So we'll copy that. And now we're going to edit the webcam2.txt file that we just created, the copy of octopi.txt that's in that alternate directory that we made. So sudo nano octopi.conf.d/webcam2.txt. And we're going to make the same updates, auto to USB, and then camera options. Always remember to take the comment off. Change our resolution. You can update this based on whatever camera you're using. And then inside those quotes, -D, and then paste in that fully qualified name. Now, since we can't run two cameras both on port 8080, we need to switch the port for this second cam. So we'll scroll all the way down to the bottom, and we want camera HTTP options. Take the comment off of that. Leave the -in, but in the quotes, do -P, and set the port number. We're just going to use 8081. Now we can use two cameras. So Control X, Y, and enter to save. Now, since we've made a lot of changes, I would just go ahead right now and reboot. Do sudo reboot now. This is going to restart all the services. It's also going to make sure that everything comes up on boot as it should. And while this is rebooting, let's go over and get the cameras mounted how we want so they look correct in the GUI while we're configuring the rest of this out. So back to the front of the enclosure, I'm just going to show you this top one because it's easier to film because of that curtain, but it's going to be exactly the same in the bottom one. But our new 3D printed mount, we'll just go right here. Gets it a little further away from the print bed so the camera has an easier time focusing on it. And we can screw those down. And then your camera will fit in there just like that. And that should give you a pretty good perspective of what's going on inside here. Our reboot is complete, so we have a few other things that we need to update so that we can utilize all this. Let's go to settings. We need to add our new serial port. So remember I said I wanted to use the main one on the IP for the top printer. We have it named top up here. /dev/top. And you can save that. And we'll just go slow, refresh, and then it should now be in your serial port. There's top. Prusa baud rate 115200, and we'll save it and let it auto connect. Go ahead and hit connect. If you see your temperatures down here, that's a good sign. It's getting information from the printer. Let's move to the second one. Same thing, settings. We'll add our port, /dev/bottom. We'll hit save, or refresh. Select our new port, our baud rate, and we'll save the connection and hit connect. So we're good, both printers are working. Now we need to set up the cameras a little bit. So I'm going to jump back to the first one and go to the control tab. Now I want to verify that the correct printer is being shown in the correct camera. So this should be the top printer. Since they're both Mark IIs, it can be somewhat deceiving. So I'm going to walk over here And on the top printer, I'm just going to set my benchy. Notice there is no benchy in this picture, so this is the wrong camera. So let's swap it out. So let's go to Settings and go to Webcam. And we want to use that other camera feed, not the default one, the one we put on 8081. So we're just going to update this line, http:// your Pi's IP, 192.168.1.185 for me, and then colon the port number you set it at in your config file. Ours was 8081. And because we didn't set up HA proxy, you're going to have to take this webcam off. You just want it to say / action stream. And you can go ahead and test that. There's our benchy. That's the correct camera. If you want to update HA proxy, you can. I don't think it's necessary. You just have to be aware you can't call it by that webcam name. And make sure that you update your time-lapse port down here, 8081. Go ahead and test that so that you get the correct time-lapse. So we're good. Now we have the correct camera on the correct printer in the top enclosure. And then we can jump to the bottom one, go to the Control tab. It's not started at all. Let's fix that up. Go to Settings, Webcam, and we'll just port it direct as well. http:// 192.168.1.185. And it's on the default port, so you shouldn't need to add anything. You should be able to just test it. And there's no benchy there. So we know that's the bottom camera. And you shouldn't have to update your snapshot. You can test it. We're good there. So cameras are mounted, ready to go on their specific printer. Now next, there are a couple of plugins that I want to use for this install. The first one being a firmware tool. You don't want to have to unplug all of this, get your laptop out to flash the firmware. Prusa still puts out new firmware for the Mark II and the Mark III quite often. The last one was sometime in mid-January. But I want to be able to do that right from here. So if we go to Settings, we'll go to Plugins, and we'll do Get More. And I'm just going to search for firmware. There are a couple of these, but one specifically that works really well on Prusa. And it's called Firmware Updater. So we'll just install that. Now remember, when you install these plugins, it's going to be available on all the instances. Now that can cause some problems with certain types of plugins, but we'll talk more about that in a moment. Plugin has been installed, it's restarted. Go to Settings. If you scroll down, you'll find that plugin, Firmware Updater, and you need to fill out some information. Now you do have to install certain things based on what processor you use. The old Prusa printers, they use that Mega 2560 still. So you're going to have to use AVR to flash them. But if you hit the GitHub link right here, all of this information is available, what you need to do to get it to work for your printer. If you scroll down here, it says right here, Prusa Mark III. It's the old @Mega processor. We need to install AVR-Do. And they give you how to install those plugins. We're going to have to do it from command line. So we'll just hit this link, and it's going to give us the commands to run. All we have to do, since we're on Raspberry Pi, is do an update for the repos, and then install the plugin. So jump back to command line. We'll log back in. And we'll do that update, sudo apt update. It should only take a moment. And then we'll plug in that install command for the AVR package so that we can communicate successfully with the chip to flash the firmware. It's relatively small, it'll only take a second. And this also might be a good time to go ahead and restart your Pi. Now that we have that AVR package installed, things have reset, we'll go back to our instance, Firmware Updater, and we need to hit the Settings button up here. So the flash method is AVR. We need to select the MCU. The most common one is 2560. And then over on the GitHub, it tells you what you need to plug in for the other entries. So the path is user bin /usr /bin / AVR DUDE. You can just test it. Path is valid. And the programmer type, set it to wiring. And hit save. Now, with this installed, we have to set it up for the second instance, but you can go grab the hex files from the Prusa site. The most common board to see on the Mark II is the Rambo 13A. The 10A is really old. I've never run across one, but this is all the same hex file. This newest version is 3.12.1, but just pick the language you want. I always just install the one that's English and Czech. It just seems right. So I'll grab that and hit open. And then you can just hit flash. While that's flashing the printer, we can head over and set up the second one. It's on the right serial port. We're using AVR 2560. User bin is the location. And programmer type wiring. You can test that and hit save. And now you can flash the file to the bottom printer. So we definitely like to have that firmware updater tool. That's going to save a lot of time. It would save even more time if you had more printers. But there's one more plugin I want to address here, and that's OctoEverywhere. I like to install it on every printer that I have running Octoprint. It allows you to remotely monitor your printers and get notifications what your printer is doing. The install is complete. We'll go ahead and restart. And after the restart, we're going to get this OctoEverywhere wizard. We can go ahead and complete it here, but remember, the plugins, when you install on multi-instance, they're going to be on both. And we have to take that into account. But let's go ahead and complete this one. We'll hit complete setup now. It's going to take you to their site. You have to create an account, but it's just a username and password. There's not much to it. And just name your printer. This one is going to be Mark II _ top. Finish setup. What this does is creates a key that's shared over the web so that OctoEverywhere knows your specific printer. And each one of those keys has to be unique. And that's where this whole plugin sharing thing comes into play. So we've got the top one, but if you go to the bottom instance, even if you refresh, you're not going to get that wizard. If you go to settings, it's not down here in your plugin list. If you try to disable or uninstall, then reinstall, things get kind of out of sorts. What I recommend you do right now is go back to the first instance. You can finish your install, and then go up to the power button and just hit reboot system. When the reboot is complete, that should allow the second instance to grab its plugin, install it, and then grab its own secret key. So we'll go ahead and reload the bottom one, and now you'll have the message you can finish your OctoEverywhere install. We'll just name it Mark II _ bottom, finish setup. It created its own key, and now you have both in OctoEverywhere. So it's not difficult to get them both in there, you just have to know the sequence that OctoEverywhere expects. But now we're good to go. And then the final super convenient tip is one that probably everybody knows, but I use Prusa Slicer for all my printers, and you definitely want to get specific profiles set up so you can send files directly to that printer. So in Prusa Slicer, set up whichever profile you wish, but make sure you grab the Mark 2.5S profile or the one for your printer, and then you can go to printer settings. And then if you hit the cog up here, that's going to give you the specific physical printer settings. And we want one for the Mark II top and Mark II bottom. So let's do Mark II _ top. It's based on the original 2.5, and we're using Octoprint. So then back to Octoprint top, we'll go to settings, API, and we'll copy our API key. Back to Prusa Slicer, you can paste it right here in the API key, and then your host name, IP, just punch that in. And this is the first one, so it doesn't have a port. You can go ahead and test it. We're good. So go ahead and hit OK. And now we have a printer configuration for the top printer. And we want to make one for the bottom one. So I'm just going to select the Mark 2.5 profile again. Hit the cog. We'll call this one Mark 2 bottom. Octoprint hostname, this time 192.168.1.185, and then just put your port number in there, which the second one is 5001. Head back to bottom, settings, API, copy that key, paste it right here. Do a test, and it's connected. Hit OK. Now when you're sending files to your printer, you have both your bottom and top printers. You can send files directly from Prusa Slicer. It just makes the whole thing a lot more convenient when dealing with files and starting prints. So there it is. Our Enclosure Restack project is complete. We have two 3D printers in the same footprint. They're both enclosed, so we can use a little higher temp filament, as well as monitor them remotely, send them files, and we can view them on multiple cameras using one Raspberry Pi. Now, there's a lot of benefits to this setup, but mostly this video series was for me to show you how I get things done around the shop. It's not always easy to put things together to make content, but I do things like this all the time, and I want to share all the tips and tricks that I know with you. So, hopefully you like this video series. That will be it for today, but I'll see you really soon on the next one.